Thank you once again for making time with Initiative Smart Class. The last time we promised you that will be coming your way again with another question where the observations repeat themselves. You were asked to find the mean of a certain set of numbers, and we concluded that those numbers in the question were not repetitive, in the sense that the numbers were not repeating themselves. If you remember, we used 11, 12, 13, 14, and 15. And we stated that since the numbers are not repeating themselves, we settle on the formula summation x sub I all out of n. That is the x bar, which is the mean. We settle on this formula. And we stated that I takes values from 1, 2, up to n. That is what we stated. That when the observations are not repeating themselves, we settle on this formula to find the mean of the given set of numbers. Today, we have a different set of observations because in our question, you can see clearly that the 11 repeats itself 3 times. 12 repeats itself 2 times. At least one of the observations does repeat itself. That is the point we are making. But 13 appeared only once. 14 appeared 3 times. And 15 appeared 4 times. Find the mean of the following numbers. So we have taken observations, and these were the observations that we have in the data set. Now we want to find the mean of these numbers, and we are saying that since the numbers are repeating themselves, for this time around, we want to use another formula that is more advisable to be used when the data set, the elements in the data set repeat themselves. What formula do we use then? We use the formula x bar is equal to the sum of all the fx divided by summation f. X bar is equal to summation fx divided by summation f. Normally or ideally, this is how it's supposed to be. I here, and then I here. And then we conclude that I also take values from 1 up to n. I also takes values from 1 up to n. But this one, we need to draw a table. We need to draw a table for us to appreciate the formula very, very well. So what we are trying to say is that x bar here will be equal to sum all the fi xi divided by sum all the fi's. So what we are trying to say in this sense is that we will add f1 x1 plus f2 x2 plus f3 x3 plus dot 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 plus fn xn all over f1 plus f2 plus f3 plus dot 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 plus f sub n. This is how to find the mean of this particular data set. I'm doing this to explain the meaning of the formula f1 x1 f2 x2. The meaning is that each observation appears with its own frequency. Each observation appears with its own frequency. Each observation appears with its own frequency. It is advisable that we draw the table for us to appreciate what we mean by this formula. So by drawing the table, we have the numbers here. And we have to tally. We have to tally. And again, when you tally, the tally will give you what we call the frequency. Based on the tally, we generate the frequency. And then the fourth column will give us what we call the fx. Fx. That is frequency times the x. Frequency times the x. What numbers are we dealing with here? The numbers we are dealing with here includes 11, 12, 13, 14, and then 15. We arrange it in ascending order. 11, 12, 13, 14, and then 15. 11, 12, 13, 14, and then 15. Let me write it more clearer. Let me write it more clearer. In this case, because the numbers are repeating themselves, you choose only one. 11 is appearing 3 times, but on the table, you choose only 1, 11, because you are going to tally to know the number of 11s in the data set. 11, we come to 12, 13, 14, and then 15. You choose only one to represent the numbers that repeated themselves in the data set. Although 11 appeared 3 times, but we chose only one. Although 12 appeared 2 times, we chose only one. 13 appears once, yes, we chose only one. 14 appeared 3 times, but we chose only one. And 15 appeared 4 times, but we chose only one. So we do what we call tallying. Tallying. If you tally This becomes, you cancel 11 and then you tally. You cancel, you tally. You cancel, you tally. 12 2, as you cancel, you tally, you cancel, you tally. We advise students to use a pencil to do the cancellation, because there is a likelihood that if you want to look at it and then write the number of tally and then the frequency straightforward, you may undercount it or overcount the observations in the data set. So we advise students to move systematically by cancelling and then tallying, cancelling and then tallying. We have actually chosen this simple question to illustrate the principle behind the subjects, such that if the student should encounter a question where the data set is more than this, he will know the principle and then apply the same principle to solve the question. Now, 13, if you cancel, you tally. 14, another 14, another 14. Then 15 also appears 4 times. It's clear. But like we said, we cancel, we do our tallying, we cancel, we do our tallying, we cancel, we do our tallying, we cancel, we do our tallying. Clearly, based on the tallies here, we generate our frequencies. We tallied 3 times here, so it means the 11 here is 3. 12, 2, 13, 1, 14, 3 times, and then 15 also, we tallied 4 times. So 15, we tallied 4 times. Now let's come to our fx. We need to understand what we mean by the fx. We earlier on defined the xi from the previous example, that the xi represents the observations. The xi's here represent the observations. In this case, we are using 11 as the x1, 12 as the x2, 13 as the x3, 14 as the x4, and then 15 as the x5. We are using the table. We are not counting all the observations, but we are using the table. Now, fx means multiply the frequency by the corresponding x. So the numbers here represent our x, and the frequency here represents the frequency. So we multiply x by f. So f times x. When you see fx here, fx is the same as f times x. That is the meaning. Just like we know AB to be equal to A times B, we know BC to be equal to B times C. Fx also means multiply f by x. So this is what we mean by fx. We multiply all the x by the f. 11 times 3 will give us 33. And then 12 times 2 will give us 24. 13 times 1 will give us 13. And then here, 14 multiplied by 3. 14 times 3. To make it easy for you, I've already explained this thing that 3 times 14, if you split this, it becomes easy for you. 10 plus 4. 3 10, 30, 3 4, 12. And that makes it 42. 42. Then the last one, 15 times 4, will be 60. 60. 60, which is 60. So this is how we generate our table. This is how we generate our table. To better understand what I have written here, the expansion of this formula, let me explain it here. The first row represents our F1, X1. The second row represents our F2, X2. The third row represents our F3, X3. The fourth row represents our F4, X4. And then the fifth row represents our F5, X5. F1, X1, F2, X2, F3, X3, F4, X4, F5, X5. That is the meaning. Because the formula says sum all the FIXIs. So we sum everything here. That is why when the students are doing the calculation, after getting Fx, they just come and write the sum of f of x is equal to. But the actual thing is f1, x1, f2, x2, f3, x3, f4, x4, f5, x5. When you add all of them, because each observation here appears with a frequency. Each observation appears with a frequency. And here we are actually dealing with 5 different observations, but they repeated themselves. F1, X1, F2, X2, F3, X3, F4, X4. Each of them occurred with its own frequency. So the summation of the Fi's, Xi's now is equal to, when you add everything here, you will be getting 172. 172. And then when you sum all the frequencies, F1, F2, F3, Fn, here is your F1, F2, F3, F4, F5. When you sum all the frequencies, the sum of all the Fi's is equal to 13. When you sum all the Fi's, the answer will be 13. Now, if you go back to the formula, the mean is equal to, the mean, which is x bar, is equal to the sum of all the Fi, Xi, all over the sum of Fi's. And we have explained this one as you sum everything here and then you divide it by the sum of all the frequencies. So by summing everything here, we had 172. And then by summing everything down here, we had summation of Fi to be 13. Summation of fi to be 13. So our final answer will be x bar is equal to 172 divided by 13. Because the total frequency here is summation of fi is 13 and summation of fixi is equal to 172. 13.231. That is by leaving it in 3 decimal places. I prefer leaving answers in 3 decimal places or many decimal places, in the sense that the more the decimal places, the accurate the answer. Because when you take some of the numbers off, you are reducing the accuracy of the answer. So that is how you find the mean of a set of numbers or a set of observations that repeat themselves. It is better you use this formula, especially when the data set is too large. Especially when the data set is too large. When you want to use the other formula, you find yourself wanting. Like I said, that is not to say when you use the other formula, when the set of numbers are small, you get it wrong. You can equally use the other formula and you get the same answer. Let's quickly try the first formula and see. And you will see that the answer should be the same. But I'm saying we should use this formula because when the data set is too large, you cannot use the other formula. By using that formula, it is simply x bar is equal to summation xi's, the individual observations, all over n. That is the number of the observation. And this is simply adding all the observation, x1 plus x2 plus plus xn, all over n. The meaning is that just add all these observations or add them straightforward. When you add them, your x bar will be equal to, by adding them, you still get your 172 divided by your n. And that n here is 13. Which is equally 13.231. 13.231. But our advice here is that when the data set is too large, a lot of numbers, 1, 2, 4, 5, about 40, it is not advisable to use this one. You may even end up getting it wrong. And you cannot write the observations individually. If, for instance, the data set is like 500 or maybe 40 or 50, you need to use a table to do the analysis, get your frequency, get your fx, and then finally come out with your answer. For the sake of the demonstration of the principle behind it, that is why we chose a data set with only 13 observations. So we can demonstrate how to use this formula. So if you did not get the opportunity to watch the first video, kindly visit the first video and look at how we solved for the mean in that question when the observations were not repeating themselves. God bless you so much for making time with Initiatives Math class. In fact, we are ready to demonstrate a lot of principles behind most of the questions that are challenging students in the SHS and then JHS. We always urge you to like, follow, and also share the videos for others to equally benefit from the information we are giving out to the general public. If you have any challenge, you can call our numbers or send a WhatsApp message that will be ready to help you. Like I've always been saying, let me also state it again, that the online classes is still going on. If you are interested in the online classes, we use applications that will let you equally enjoy the classes and also have the opportunity to access questions about certain things you do not understand. Our numbers are readily made available on the video, and any of the videos that have already been made available to you, if you watch any of the videos, you can see our numbers boldly displayed. Once again, God be with you and God bless you so much. Follow us and continue to share the information to the good people of our country and then your friends. Bye-bye.